Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency focused on building live video applications. We're here to help you take your application live. You can learn more about us at WebRTC.Ventures. Thanks for joining us live today on YouTube, LinkedIn, and Twitch. Welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this. For today's episode, I'm very pleased to have David Zhao join us. David's a CTO and co-founder of LiveKit, an entrepreneur and builder heavily invested in open source software. He previously co-founded EV Labs, a platform for optimizing search on Android devices. After the acquisition of that business by Medium in 2019, he founded LiveKit in 2021. David will be discussing the open source WebRTC ecosystem with us today and where LiveKit fits, as well as how LiveKit achieves end-to-end efficiency. Thanks for joining us today, David.
Thank you, Aaron. It's great to be here.
All right. Well, it's great to have you. Definitely looking forward to this conversation today and learning more about LiveKit. We've certainly heard a lot about it, as well as Pion that's used behind the scenes in LiveKit. Yep. So really interested in seeing more about your take on this. So why don't we go ahead and switch over to your slides then?
All right. Can you guys see everything okay?
Yep, we're all set.
Awesome. So yeah, I'm here to talk about end-to-end WebRTC. So first of all, just to get the elephant out of the room, that people sometimes ask me, like, why do you need an end-to-end approach to WebRTC? Isn't it already pretty simple to work with WebRTC? Actually, I'm just kidding. Nobody ever asked me that. WebRTC definitely looks pretty simple, right? Like you create a peer connection, set offer, answer, perform the exchange, and there you go. It's actually quite magical how calling a couple functions connects two machines anywhere on the internet together. But I gotta say, this is only the beginning. First, the question is like, how do these things get exchanged, right? There's this thing called signaling that I think all of us are very familiar with. How do you get a text string, a set of string from one machine to another? While WebRTC is peer-to-peer by definition, signaling is not, unfortunately. And if you ask, like, well, there must be some way I can just, call an API or something and get signaling done, but not really. You got to bring your own signaling server. And in most cases, I think people use something like this, right? A WebSocket server plus send JSON messages across. And on the other end of the recipient, it's a server that's running the WebSocket, coordinating all these different connections from different clients. So that's signaling, and you got to build that yourself. So if you're building an application, let's say you finish your signaling server. Now let's look at running the app, right? So for most people, these are the three browsers that people care about. So Chrome, and I'm including all the variations of it, like Edge and Brave, Safari, and we have to care about Safari because of the Apple ecosystem, iPhones and iPads, etc. And then Firefox. For better or worse, WebRTC doesn't actually work the same way across them. I mean, yeah, they're supposed to implement the same spec, but there are all these differences that kind of trip people up, and it is your job as an application developer to handle them, right? Like this API might do one thing on one browser, but behave just a little bit differently on another. And let's say you're trying to build for mobile, right? The good news is that for your own apps, if you're shipping your own binaries, so yeah, you can compile in whatever you want in it. Now the bad news is that you kind of have to compile the WebRTC by yourself. So Google used to maintain binary distributions for WebRTC for mobile. They had SDKs for iOS and Android. They used to publish the binary versions of it to CocoaPods and wherever the Android one's hosted at. But for some reasons, they stopped updating them sometimes in 2020. So if you use those binary release versions, they're going to be very out of date, about 2 years old. Let's see, you do go through all that. Then let's talk about connectivity. So, for the most cases, UDP connections work pretty well. You can get two peers connected from anywhere. But then, like, as you dig deeper, you start seeing all these terminologies, ISTCP, stun, turn, and what is turn/TLS thing? How do these things fit together, and how does one set them up? And it turns out there are separate servers and different components that you need to build, and you have to coordinate how they work between the clients. Okay, so you go through all that, and then in practice, in the perfect world, networks are perfect, it just works great. But in the real world, you have disruptions. Sometimes you have spotty Wi-Fi, right? You lose connectivity for a few seconds and then come back. How would that kind of trigger different events in the APIs? Or maybe the user is switching between cellular to Wi-Fi and going through that. And how do you make sure your session, if you're in the meeting, doesn't really become disrupted? How do you handle these reconnection events? And because you're having different connections, a signaling connection with WebRTC, these events have to be handled differently. You have to detect them and also figure out, like, what happens when one of them gets disconnected? What do I do? And especially for the signal server, what happens when you're disconnected and then somebody sends you an offer, right? And you miss that. So let's take a look at the code. It looks pretty simple, but there are a few caveats here where when the peer connection becomes disconnected, it doesn't actually mean permanent disconnected. But when it fires failed, then it actually does mean permanently disconnected. So just some nuances to pay attention to. And then the big kind of question, multi-user, right? How does that work? If you're doing P2P, as you add more users in the room, you quickly realize that, this chart, I think people have seen in different places, that it's basically an N-square problem. As with every user joining the room, you have to send your media to them once again. So very quickly, you're going to start exhausting the user's bandwidth as well as compute capacity. Generally speaking, like after 3 users, more than 3 users, you don't want to do P2P anymore. Okay, so you need a media server, right? That's typically an SFU or an MCU. And so you got that set up. What does the client set look like? Well, the WebRTC APIs are track-based. So when you have a peer connection and receive a new track, you get an event for that. But if you're trying to work within the standards, then there's a pretty big challenge of like coordinating who's published what, right? In a multi-user scenario, people might be changing their state frequently, publishing tracks, removing tracks, etc. So you got to handle all that stuff. And WebRTC doesn't have the concept of users. It's a peer-to-peer protocol natively. So there are a lot of issues that one has to deal with to build a WebRTC application. And ultimately, we get compared to this, right? We get compared to Zoom. It's not a fair comparison, not at all. Like you're comparing a set of protocols to a vertically integrated application. But at the end of the day, for end users, this is our competition, right? Users don't really care about what underlying technology you're using, how it's implemented. They just need the application to work. And one particular thing that Zoom does really well, here's what we're looking at, is that it just works and it's efficient. So we're looking at a 5x5 grid. So you're pulling in 24 videos. They're able to do that at only 2.4 megabits. And if we just put some things together using WebRTC and doing things naively, we would be consuming 38 megabits just to pull 25 streams, even with by using a SFU or something like that. So as we started talking to people, we quickly realized that everybody is solving the same set of problems, right? Like all the problems I described, every application developer that's shipping end product to the user is responsible for all those things. So that's kind of the genesis of why we started LiveKit. So LiveKit is the open source stack for WebRTC. And we took an end-to-end approach to the problem. So what does that mean? It means We have an SFU, so we took the SFU route. It's a piece of code on the server side that is built on Pion WebRTC, and that's actually been a huge kind of accelerant in our progress because Pion was just incredibly easy to work with. We have a set of open protocols that really defines what the server's capabilities are and how that can be integrated with clients. We also publish our own client SDKs. We have SDKs for all the major platforms: iOS, Android, Mac, Windows, Flutter, and obviously the browser. But we also have a set of tools to help people deploy LiveKit. So that's kind of what we consider as end-to-end. We made the first commit to the repo in September in 2020, and the product was released in July of 2021. And the entire stack is licensed under Apache 2. So, we have a lot of people contributing to it, as well as forking it and kind of modifying things to solve their own problems. Our goal with LiveKit is really to solve the undifferentiated problems with WebRTC, right? So, you have WebRTC and all of the protocol it encompasses, but on top of that are things that we've built and makes it easy for the application developers. So that includes multi-user capabilities, authentication, signaling, and also developer experience. Like, how do we make something that's accessible and easy to use? So let's take a look at our solution to some of the challenges that we discussed before. First, we've got connectivity, right? So how do you make sure this always works? Our goal is to get to 100% connectivity, as close to that as possible. And it turns out it involves using several different techniques to get there. So you have ICE over UDP, which is a primary route that works most of the times. And then you also need ICE TCP in case some networks just disable UDP altogether. Their firewalls or routers are configured to not support UDP. And then for corporate networks, why do we need turn TLS? It turns out that not only do they block TCP, they would actually disallow any connections, any unencrypted connections over most ports. So the only connections some firewalls only allow is 443. And there are kind of packet sniffers as well that ensures that they're encrypted packets that are going through. And then you also have edge cases, right? Like things like UDP connection sometimes gets dropped, not UDP connection, but the connection gets made, but some of the UDP packets we see higher loss than we do for TCP. And routers sometimes have QoS policies where they prioritize certain types of traffic, and we'll have to deal with that to ensure that the client actually doesn't see any issues. On top of that, there are random router and ISP issues. The list goes on, right? Like all these quirks that are built into this complicated networking stack. And at last, like another reason why we have a presence on the client side is that for managing network disruptions, the client really has to be the one to do it. You need the client to be very involved in discovering connectivity issues and kind of initiating reconnect requests. And then for multi-user, as I mentioned, WebRTC is designed to be peer-to-peer protocols, and none of these make sense in the core product protocol itself. So we wanted to have a higher level of abstraction for app developers. So if you're doing multi-user applications, you get a room. Inside of it, you have participants, and everybody can publish tracks. And there actually turns out to be quite a bit of challenges along the way as we built the stack. It's that managing state is very difficult because in a real dynamic system, right, where people are joining, publishing tracks, muting themselves, unmuting, a lot of changes are happening in the state but what you want is for everybody in the room to see the same view, right? So there's a bunch of synchronization work that happens behind the scenes. But also large rooms is another kind of thing that we wanted to handle correctly, is that, now conferences are getting larger. You have 50 plus 100, 200, 300 people rooms all the time. And how do you manage that? Which leads me to the next point about efficiency. So, I previously showed the slide with Zoom with 25 videos, and they're handling just fine at a very low bit rate. So here what we're looking at is our example app, and this is open source as well. You can get it from our React repo. Without any kind of work on the application side, you can actually get a 5x5 grid at about 3 megabits. And we can reduce the resolution even a bit more to squeeze it to kind of match zooms if you want, but in here we prioritize resolution a little bit more than just raw bitrate. So let's talk about how we did it, right? Like what set of technologies are involved and how do we accomplish this? So there are 3 things that were used, and I'll go through each of them: simulcast, adaptive stream, and dynamic broadcast. So simulcast, I think a lot of you in the audience are familiar with this, where essentially it's every stream is published multiple times to the SFU, and the SFU can make a decision on which of the streams to forward to the subscriber. What's really cool about simulcast is that it really decouples the publisher from the subscriber, right? Like when you're publishing, you really just worry about what streams that you're publishing, your own constraints, network and CPU bound, but you don't really have to care about what subscribers' situations are, and kind of pushing that problem to the SFU. And this also works with SVC, but it works slightly differently. I'm happy to go into that later as well. But so once you have that, and then let's take a look at the 3 streams. I have this illustration here because it could be really hard to appreciate that just how much more bitrate that a higher resolution uses. So for a 720p video compared to like a thumbnail resolution 180p, it uses 16 times the amount of bandwidth to transmit it. So it's way more efficient if you can just send a resolution that is small, that that it is small enough to match what the UI requirements are, versus like the inefficiencies that are created is when you start sending large chunks of video down. So it's a pretty simple idea, right? Like how do we match the resolution very tightly and have a set of signaling protocol to make that happen? So here's kind of the signaling protocol that we're using for adaptive stream. There's a new API introduced in the core protocol where the subscriber can tell the SFU like just about what do I desire, right? It also communicates visibility information. So here my element is visible. I'm trying to get 500 by 300. The SFU can just switch the client to that layer. And when the subscriber when the video element is hidden, right, the best thing to do is just not to send any streams down. So you can send another event to request a pause. So that works pretty well. And so we want to push that a step further, meaning like, how do we do this automatically, right? Rather than having a client application issue a bunch of different requests and like, coordinate all these things, can it just work automatically? It turns out that it can. So there are a couple of challenges, right? So how do we know if an element is visible or not? I mean, if you're the application, you hide a video element, yeah, you kind of know, but how do we know that automatically without being in a path of control? So there's this API called Intersection Observer that all browsers support. They've actually supported this for a while. It's not super well known, but the way it works is that it detects visibility between any two elements on the page. So here we're using the document element, which describes the visible portion of the page, and the video element that's of interest, right? So every time the visibility changes, we're going to get a call, and we can start managing that automatically. So for resolution changes, it's kind of similar. There's a thing called Resize Observer, where similarly, you can just attach it to a video element, and whenever the user resizes the browser, or if your layout of the page changes, right? Say like you're switching from a grid view to like a full screen view, that can also be handled automatically. So putting that all together, this is what adaptive stream looks like, right? So here is a pre-recorded video conversation between me and Russ, and he's currently presenting a screen share. So as you can see, the videos are pushed to the side in a very tiny thumbnail. And the bitrate that it's displaying in this little debugging interface, it's pushing about 130 kilobits per second, including audio and everything else. So what happens when the UI changes, right? Let's take a look. So he's stopping the screen share. We're in full screen. So notice how adaptive stream increases the requested UI resolution, and now we're receiving a 720p stream from Russ, and this is like 1.7 megabits. That just worked automatically without us having to do anything on the application layer. So to use adaptive stream, all one has to do is just to pass the flag in adaptive stream equals to true, and then bind to the video element. So this attach call allows our SDK to place all these different listeners and observers on top of the video element. Okay, so that's the subscriber side. Pretty simple so far. Let's flip on to the publisher side, right? Very similarly, the publisher doesn't have to keep publishing when no one's consuming streams. As you can imagine, if you have like 100 people in a room, but everyone's just looking at the speaker, right, in the focus view, then most people actually don't have to keep sending, 2-3 megabits of data to the server constantly. So we can similarly, the SFU can have a layer of intelligence to keep track of, for all of the video layers that one's publishing, who's actually consuming them, right? So once you kind of keep accounting, basically a counter of number of consumers, you can send an update to the publisher, right? So here, this signal message is subscribe quality update. It tells the publisher, hey, only the highest layer you should send is 360p because no one's consuming the high layer. You're in a different UI view that doesn't require such a high video resolution. And the client SDK can then take that and to pause the published layer. So how does it do that? It's pretty simple. WebRTC actually had this like pretty cool feature for a while where you can grab a sender's parameters. You have all these different senders. Each sender is represented as each sender is for a simulcast track. You can manipulate the encodings, and for each of the layers, set it to active or not. Right. And once you make the updates, you can set it back onto the sender object, and the right kind of manipulation would be applied. So yeah, I've been talking for a while, and this is LiveKit, and you can check us out at GitHub on GitHub. It's actually pretty easy to just install the server on your machine. It takes 5 minutes to try and get a demo up and running. So check it out. With that, I'm going to turn it over to questions. I'd love to answer any question anyone has.
Awesome. Thanks so much, David. That's really interesting. A lot of cool, powerful stuff in LiveKit for sure. So really appreciate you taking the time to share that with us. And so one of the items you talked about there in detecting visibility and the intersection observer API in the browser, you talked about that, using that to determine if the video is visible or not. So I'm imagining this being used in a like in my mind, I'm thinking about like a large video call. Let's say it's an ed tech, a classroom type of scenario where you have lots of students perhaps in the room, and you can only look at so many of them on screen at once, right? And so you've got those 5x5 grids that you talked about, but maybe you're really scrolling through multiple pages of them if you're trying to see everyone, right? Pretty common interface technique. So in that sort of scenario, if someone is out of the view, then that, let's say, it's the teacher looking at that, then they're only going to receive the 5x5s, but as they scroll down, would they start to then receive the other videos as they scroll down the page? Is that how that would work?
Yeah, totally. So what's cool about the intersection observer is that as the elements become visible, right, we can detect that right away. And then we can immediately send a message to the server side to say, hey, these elements are now visible, give me video. And it actually takes less than a second for the videos to start popping in. Nice. Even if we need to send a message to the publisher to say, hey, start publishing now, that entire round trip, back and forth is under a second.
Oh, that's great. And that's exactly what I was going to ask next, is what that lag time is. So that's really low. That's excellent. And it's a similar sort of lag time perhaps as in the demo that you were showing when Russ comes on screen and his resolution adjusts pretty quickly on that same order of time scale, I imagine, right?
Yeah, right around, and that's exactly what's happening. The reason why it took a couple seconds for the resolution to increase to the level that we wanted is because
Hmm.
the encoder was not actually encoding the high resolution bits, right? So initially, when we just sent that stretched the UI immediately, it was stretching like a low resolution video higher, so it didn't look very good, right? But then the high layers eventually started coming in pretty quickly.
Hmm. Nice. So tell us a little bit more about the decision to base LiveKit on Pion, and how do you work with Sean and the others behind the Pion project?
Yeah, for sure. Pion's a great like open source community that Sean managed to create. We are our reason for choosing Pion is pretty simple. It's actually we took a look at different WebRTC stacks, and most of them are in C++, and they're just a lot harder to work with, right?
Hmm.
And a bunch of us have tons of experience with Go. We've been Go programmers for a while, so it was very natural to kind of for us to look at Pion. Another thing that we kind of realized quickly after was that for server-side WebRTC, like Go is actually a great fit, because the set of problems that you have to deal with is how do you serve quite a few users at the same time, right? Because
Hmm.
SSFU, you're not really doing anything computationally heavy. It's really just managing the network connections and managing different users and serving them. So Go turned out to be a great choice for that. So we're really happy with the decision to go with Pion. Another thing that like I want to mention about Pion is that the community is really awesome. Like there's just tons of people in that are contributing to the project, and Pion is used by a lot of companies as well, for their internal WebRTC stacks and other things. So it turns out whenever there's a bug or whenever there's a piece of improvement, people are actively maintaining that. So it's not just Sean. It used to be just Sean kind of doing most of the work. Now it's been now it's quite a bunch of folks that are just kind of making it better all the time.
Yeah, that's great. I mean, it's interesting how WebRTC as a standard was initially talked about a easy to use JavaScript interface, but now we have kind of scenarios like Pion on top of that, and then LiveKit further on top of that as ways to further abstract it. Because it's like you said at the very beginning, no one ever says WebRTC is easy to use, even now,
Yeah.
and it's I guess it is a lot simpler than what you would have to do prior to the WebRTC standard, right? But as the capabilities of the standards and capabilities that we can build into websites because of increased bandwidth, et cetera, obviously our demands go up on it higher. We're trying to do more complicated things. We're trying to put hundreds of people into a call, perhaps, that sort of scenario. So no, this is really powerful. I think it's last month on WebRTC Live, I was speaking with Chad Hart from WebRTC Hacks, and he did an analysis of different open source projects in GitHub. And even though we're hopefully the pandemic is winding down, and somewhat related to that, this tremendous peak that we had in WebRTC has passed, but certainly usage of WebRTC in general is still much higher than it was before the pandemic. Things have changed and, are not going back. And Chad's analysis showed there's also still lots of interest in open source WebRTC projects. And so, LiveKit's evidence by that was mentioned in it. What's your view on the state of open source WebRTC today in general?
I think it's a really booming ecosystem. I mean, there's tons of projects in open source kind of dealing with WebRTC. Pion's the example. There's also Rust port of Pion, WebRTC.rs. That's pretty awesome too. There's all these different SFUs, LiveKit being one of them. It seems like a really booming ecosystem, and I think I'm a big fan of open source, right? Like it really allowed us to see all these different applications that we're using without having to sell to them as customers.
Mm-hmm.
And it also gives people kind of a degree of freedom where you don't have to depend on the CPaaS, right, to build your product. You can actually own the entire stack from from your application to kind of the infrastructure layer as well. So yeah, we're very bullish on open source, and how, and the WebRTC in general, like it's not easy to use, yes, but it is pretty amazing at what it can do, right? Like for people that are my last company, we tried to build low latency video over the internet for gaming. That was kind of our initial project before we pivoted to more of the search side. And we had to build all that low level protocol stuff from scratch, even from like the UDP layer, right? Like how do you handle all that? And so it's kind of incredible that WebRTC just solves that problem well. And yeah, the multi-user stuff is not part of it, and connectivity, all these things are not part of it. But it's all layers, right? It's just all software. As requirements can become more complex, as kind of the use cases that you're trying to pursue becomes more difficult, you kind of layer different abstractions on top.
Absolutely. So is that how you became interested in WebRTC then? Was through some of those challenges in gaming?
Yeah. So by then, so my last startup in 2013, 14, we started trying to build like streaming mobile apps, from running mobile apps in the cloud and streaming through mobile devices. The company was called Voxel, and we took a look at WebRTC. By then, it hasn't even made it onto mobile yet, right? It's like, kind of like a Chrome only thing back in the day. So, and we didn't really, without going through the problem, it's very easy to underestimate it. So we thought, hey, how hard can this be, right? Like we can build the stack ourselves and kind of see how that works. And we did, and it worked, but it just became visible, like we weren't solving all these problems as well, and WebRTC has evolved quite a bit since then. That's how I kind of first heard of WebRTC and took a closer look, but it wasn't really until the pandemic that we got really serious about building something with WebRTC, and that was the inspiration of starting LiveKit, is that we talked to our friends that are building, everybody's building like video-based experiences during the pandemic, because we're locked down and couldn't go anywhere. So between our own experiences and other friends' experiences, it kind of made it visible that, yeah, it's powerful, but it's kind of missing something, right? It's not quite as easy as we want it to be. It doesn't really solve kind of the edge cases as much as we want it to solve. So how do we kind of cover that? How do we make that better?
Yeah, absolutely. I've got a question from Guillermo Prado, who asks, is there a bridge to connect to SIP and VoIP in LiveKit, or are there plans for that if there's not now?
There's not currently. So we've been asked that actually quite a lot by folks, especially folks that are moving from existing providers that have that support. So it's on our radar, and we are looking to build a bridge to SIP, just to make it very easy for you to connect to that VoIP world.
Excellent.
It's on the roadmap, but it's not in the product today.
Sounds good. Thanks, Guillermo, for your question. So does, am I correct in understanding then that your strategy with LiveKit is not to focus on any particular use case so much as, I think you talked about solving the undifferentiated problems, whereas going too specific on a particular use case might cause you to work more on differentiated problems, right? Is that correct? Or are there any particular use cases that you see LiveKit as most valuable in, most interesting?
Yeah, so I think you're right. We're like, our main focus is solving the undifferentiated problems, right? How do we give application developers a set of tools that they can just build wonderful experiences with? But there's a few areas that I think we are a bit more focused on. One of them is reliability. I guess that's more undifferentiated. The other is multi-user and scale. How do you handle kind of large use? Not everybody needs them, right? If you're doing a telemedicine, it's usually one-on-one. You don't really care about the scale. But if you're trying to do more broadcasting, right, low latency live streaming and stuff like that, then the scale really matters. So that's one area we're pretty focused on. The other area is just really making it easy for kind of for you to manage all these different state challenges, right? The synchronization of state and dealing with that on the application layer is actually quite cumbersome, and it's very highly error prone, as we've seen. So yeah, I'm also excited about like another particular use case that people don't often talk about, which is robotics. So there's actually quite a lot of cameras and autonomous robots that are operating, and one of the things that WebRTC brings to that is, like there, especially if you're trying to remotely control something, or to see kind of what the robot is seeing live, you need low latency and you need that level of reliability. So we're seeing a few use cases being built in that space. That's quite exciting.
Very cool. Yeah. I think that is a very interesting use case for sure. Now, the documentation around LiveKit describes it as an opinionated end-to-end RTC real-time communication solution. Can you talk a little bit more about how LiveKit is opinionated and what those sorts of trade-offs that you will have made in architecting it?
Yeah, absolutely. I think the opinionated part is that there's always trade-offs with like how standards compliant that you are versus like how what is your ability to layer on higher level abstractions, right? So if we wanted to say if we were to work with any of the client tools that already exist, then kind of we're bound by certain ways in terms of what can we do on the server side, what can the protocol do, and so opinionated means kind of we're taking a stance in terms of, okay, we think this is kind of 95% of users are going to be happy with these decisions. So instead of having them deal with it or try to assemble the pieces, we're making those decisions for them at the framework level to say, for example, one example is connectivity, right? How does reconnection look like? Like ICE restart, you have to kind of manage that thing, and you can reconnect to your server to the other side. But what is that order of operation, and how do you manage that in conjunction with the signaling channel? If we left that to the user, they may be able to deal with it in different ways. But if most people that are wanting kind of the same solution, then we should kind of take a stance and just build that into the framework. Right, to kind of solve that challenge. And over time, we did see people wanting, who wants, for example, someone contributed to the open source project to say, I want a different reconnection policy, right? Instead of only reconnecting n times and waiting, here's a back off, I wanted to keep reconnecting, right, forever. And this particular user that wanted it contributed a custom reconnection policy that like does whatever he wants. So I think we take our opinion stand, but we also listen to users, and if they are wanting something different, then we want to make it possible for them to kind of tweak the framework to their liking.
Yeah. So by virtue of being an open source project, there is still that ability to change direction a little bit or change implementation a bit, but obviously there are a lot of best practices that in many WebRTC application development scenarios have to be kind of rebuilt with every project. And you all have built in most of that into LiveKit, which is part of the power of it, right? Let's talk a little bit about the rooms abstraction layer that you put in there. And there's a lot of features that have been built into that to us. I believe you have some moderation capability, authentication capability. Can you talk a little bit about that? And again, similar sort of question, how prescriptive is that sort of functionality, and how much flexibility do people have to alter that concept of rooms if needed?
Yeah, definitely. We start with rooms because the main thing that kind of people are building is, like a meeting or a conference where you want to see everybody. But over time, we did start seeing people building different applications, like, spatial applications, right? Where you're in a video game, like a metaverse thing where you can walk around with the avatar. So over time, we started trying to make those abstractions simpler or more flexible. But one thing with naming and API design is like once you name it something, it's very difficult to change. In hindsight, we probably shouldn't have called it room, but it is a room. But you can think of a room as kind of a container of any sort,
Sure.
right?
Any sort of virtual space.
So yeah, exactly. A space is probably a better term for that. So initially, everybody in the room can see everybody else, but we kind of evolved from that world to you can selectively subscribe to anybody that you want, right? So we added layer APIs. We added an option to say, hey, when a new person joins the room, they don't automatically get everybody else's tracks. So like, there's an auto subscribe setting that you can turn off. So trying to kind of balance the two worlds of like, okay, you don't necessarily need everybody's video all the time. But yeah, some of those abstractions, I think we are learning from it. But for the most part, they are flexible enough for people to build all sorts of things, right? We have people building, as I mentioned, robotics and like large metaverses where, thousands of people gather in a space and have a conference or a meeting or remote work for those use cases. With people that are building video games using LiveKit, right? Like video game communication, and so they can see see folks that are in the game and play with them, and communicate, see their audio and video. So for all these different use cases, it seems like the abstractions are they're still standing up to the test. But that's not to say like I think we obviously we're not going to say like it works for absolutely everything out there. That's kind of a high bar, but
sure,
we do want to make it work for most of the applications that people are trying to build.
Absolutely. All right, we've got a question from Alberto Gonzalez who says, "Hi, David. What about monitoring and end-to-end testing? Is there anything that LiveKit provides or recommends for that?"
Monitoring, yes. So we have a set of Prometheus charts that we publish, or Helm charts, I guess that's the right terminology. And the server is also publishing metrics as well. So anybody who has Prometheus set up will automatically get those for free. And then they can set up kind of monitoring. There's no kind of hosted solution yet, that in terms of helping with all that, but that'll change pretty soon. I mean, we are working on services in that area. And then for end-to-end testing, can you clarify what you mean, Alberto?
Yeah.
In terms of validating the stack, we actually perform a set of tests before we release it. So given the end-to-end stack, like every release that we make, we want to make sure it's up to a certain standard. But in terms of tools that others can use, we do publish a set of tools that make it easier. So like, for example, the screenshot that I shared with a video of 25 participants. So that's actually created by our client, our CLI. So we have a command line tool that can simulate video. Like they can simulate people joining a room. You just call LiveKit CLI, load test, and pass in the number of publishers that you want in the load test. They will join your room and start publishing all these things, right? They can do both audio and video as well. So those tools would make it easier for you to test your application and validate that, or is that doing the right thing, as well as the server deployment. Like, can we get asked this often? Like, can you handle this many users on this machine for my use case? In which case, it's very difficult to answer that question, right? Like, without knowing kind of the details. So we have a tool, the load tester tool, that helps people to figure that out by themselves. It will simulate, subscribers and publishers, etc.
Perfect. Yeah, I think you anticipated what Alberto meant exactly. He says that's what he meant, simulating calls and server deployments. So awesome. And so you said that load testing tool is built into LiveKit then?
Yep. That's also open source. So you can see it actually serves as a good template for you to do anything custom to if you wanted to publish a non-standard video, not from your browser, like a static file, for example. You can do that with that particular tool as well.
Excellent. Excellent. All right. And as our time starts to wrap up here, just one final question. Can you talk a little bit more about deploying with LiveKit and how, because certainly, that's building a WebRTC application is one thing, and that's not easy, as we've discussed. Neither is deploying it. So what has LiveKit done on the deployment side to help with that?
Yeah, deploying is difficult. So we've taken two routes. The first that we have a very simple kind of deploy a single server, and there's a script that we produce that you can run it on any Linux server. Set up a LiveKit instance with all the dependencies and everything, including a turn server. It's built in, including terminating SSL. Right, one script that does it all for you on the box. So that's kind of the easy path, and it worked for most people that are building like hobbyist level applications. As you go to production and try to think about scale and how do you take users in at a bigger scale, we have a Kubernetes set of Kubernetes solutions for that. So we publish a Helm chart that's official from us that helps you to set up a multi-node cluster. It can even span different regions as well, right? So and it's quite simple that it runs a homogeneous fleet of servers that they'll figure out how to load balance between them automatically. So it's fairly simple to deploy. But I'll caveat it, deployment is never simple and Kubernetes is never simple. So, but for somebody who is familiar with deployment Kubernetes, it hopefully shouldn't impose too many new challenges.
Yeah, it's still a strong jump start into that.
Yeah,
for sure. Yeah. Excellent. All right. Well, thank you so much, David. This has been really interesting conversation. I'm definitely excited to learn more about LiveKit and to use it ourselves as well. Where can people go for more information, to contact you, to contribute to LiveKit, all of that?
Yeah, we're on GitHub/LiveKit, and everything else is linked off of there. So that would be a good central spot to find us.
Awesome. Great. Anything else that we didn't cover that you want to make sure to mention today?
No, not at the moment. It's been great being here. Thank you for having me.
Oh, it's absolutely my pleasure. So thank you so much, David, and look forward to seeing the continued growth of the LiveKit project. So thanks so much for taking the time and for all the work that you and your co-founders have done. So, all right.
Good.
Great.
Thank you.
Thanks, David.
Bye.
All right. As always, this video will be available on the WebRTC.Ventures YouTube channel, as well as on our blog at WebRTC.Ventures. Our next episode will be November 16th, and our guest will be Dan Jenkins from Nimble Ape and Broadcaster VC. We'll have a discussion about the future of broadcasting and WebRTC. To find out more about our upcoming episodes, follow us on Twitter at WebRTC.Ventures, on Twitch, LinkedIn, YouTube, and join our email list at WebRTC.Ventures. Thanks, everyone, for joining us today. Let's make it live. As a viewer of WebRTC Live, you already know how important WebRTC development is to the modern web. Now it's time for you to grow your career by learning to build live video applications and joining our team at WebRTC.Ventures. Go to WebRTC.Ventures and apply to join the next cohort of our WebRTC training program. You'll have free access to advanced courses, mentorship from our team, and those who are accepted into the second month will receive a paid development contract and join our team of WebRTC development experts. Go to WebRTC.Ventures now and earn your place in our team of video development experts.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.